7.4 Inverse Functions, Part 2. Our goal today is to figure out how do we find inverses of non-linear functions. How do we find inverses of non-linear functions? We're going to concentrate on finding inverses of power functions. So in this problem, you already have it written down on your guided notes. We got to try to remember what our steps were yesterday. So on your notes, we've changed f of x to be a y equals negative x squared, and we will discuss this other stuff later at the end. All right, so anyway, then the next step. Hey, let's switch the x and the y. So now the x goes on the left side and the y goes on the other side. Because in the table of a function and its inverse, the domain and the range switch spots. In a table, all the x's of the original become the new y's. And all the y's of the original become the x's in the inverse. So we switch the x and the y, and now we got to solve. We're going to divide by the coefficient -1 first. Do that on both sides. We get negative x equal to y squared. We will take the square root on both sides. When we take the square root on both sides, we've got to keep something in mind. So because we're going to insert a square root, we're going to include a plus or minus. Also, because I know that this is going to look like plus or minus square root of negative x, I'm actually going to start writing my formal answer. So I'm going to say f inverse is equal to plus or minus square root of negative x. That lingo is talking about the domain, the original domain. It's telling you that the original input should be less than or equal to 0. And let's think about numbers less than 0. Numbers less than 0. Numbers less than 0. Oh, wait. That's like -1, -2, -3, -4, -5. So wait a second. If I look at that answer, I'm going to be taking opposite of negative numbers under there. Wait, opposite of negative numbers. What's the opposite of negative numbers? Positive numbers. So this is telling you that you're already plugging in negative numbers. And if you take the opposite of negative, we're going to get positive numbers before that we take the square root. That's why it's okay with that negative in the bottom there, or in our answer. It's okay with that as part of our answer. Because the inputs all are negative in the original. And whenever you go to the inverse, inputs or old inputs now become your new outputs. This is saying now our new outputs should all be negative. So I'm not going to keep the plus or minus. I'm only going to keep the minus. So what I need you to do is somehow put a star by this one and explain in your notes what I just said about the plus or minus. And how do you determine which one to keep? So in this problem, first thing I'm going to do is change f of x to be just a y. Then I switch the x's and the y's. So x goes to the left, y goes to the right. Then you got to determine what to do first. Divide by -27 on both sides, leaving us with negative x over 27 equaling y cubed. How do we do the next step? When I take the third root on both sides, well then I've got y by itself. So I'm kind of at the end of my rope. I'm going to start writing my answer formally since my problem started out formally. F inverse of x equals the third root of x over 27. By looking at, wait a second, -1 over 27 actually becomes perfect cubed roots. I could rewrite my answer as negative cubed root of x over 3. So, backside of your guided notes, go ahead and do your first step. Change f of x to be a y, switch the x's and the y's. So, after you switch the x and y's, all we have to do is just take the fourth root on both sides. And then you've got to ask yourself, do we include the plus or minus? Right now I have plus or minus fourth root of x. Anytime you have a plus or minus, you've got to think about what you wrote on that front side. On that front side, when we also had a plus or minus, we had to somehow determine what dictates which one we're going to keep. So plus or minus. Go back to the domain. This is telling you what part of the domain we're going to keep. So these pieces of the domain need to be bigger than or equal to 0. Ergo, your new range should be greater than or equal to 0. So you're keeping just the positive. I could either keep the plus sign or I could just wipe it out. But my suggestion is write this separately. Don't erase the plus or minus in your notes. Keep your plus or minus in your notes and then write that answer separately. So that way you see it was a decision we had to make. We had to make that decision that we're going to keep the positive end only. Alright, so you already have this written down on your notes. What we're about to do is we're going to graph the function in one color, and then we're going to see how we could graph the inverse pretty quickly. So this is not a skill I'm going to test you on, but it is a good skill to know in case you're ever asked for it in your future. So, if I'm asked to graph negative 2x plus 3, hey, isn't that nice? It's in slope-intercept form, so let's review. Slope-intercept form. I start at the y-intercept, positive 3, and then I have a slope of negative 2. Down 1, right 1, or whoop! Down 2, right 1, down 2, right 1, and so on. So keeping in mind, you don't have to draw this reflection line, but keep in mind that graphs and their inverses reflect across y equals x because the domain and the range, or the y's and the x's, change places. Let's keep this in mind. This point, 0, 3, wait, it used to be 0.03, but the domain and the range switches. So what's our new point? 3, 0. So I'm going to plot that new point in a new color. So our new point is 3, 0. And then you pick another point, like I see 1, 1. There's a point 1, 1 on my old graph. Well, wait a second. Domain and range change. So my new point, ironically, is still 1, 1. I've got an old point of 2, negative 1. Domain and range change. So that ordered pair is going to switch. So wait, 2, negative 1, negative 1, 2. Wait, right? Yeah. I'm going to connect the points and see what my inverse looks like. And then you got to determine, hey, is that a function? So yeah, it's a function. Next one. We're going to produce a table because I have a feeling we forgot how to graph x cubed plus 3. So let's plug in some numbers. Let's plug in some numbers like negative 2, negative 1, 0, 1, 2. Find their output. We get our outputs and then we plot them. Because I just created a table, let's switch the x and the y's and look at their new points. So instead of negative 2, negative 5, this is going to become negative 5, negative 2, and I'm going to plot that point. Instead of negative 1, 2, I'm going to graph 2, negative 1, 3, 0, 4, 1, 11, 2, even though it's off the grid. And then I got to ask myself, is it a function? Would it pass the vertical line test? And I realize it looks bad, but it does pass the vertical line test. Alright, ladies and gents, you are now able to do the rest of that homework. I believe you have 6 more problems on that paper that you did yesterday. There are 6 more problems you are now able to do.